So in 5.2, we take another step forward with these systems of linear equations, and we bump it up from looking at equations of 2 variables to looking at equations with 3 variables. Now, geometrically speaking, we're not going to go into depth about this, but the difference is equations in 2 variables we know represent lines, which are 2-dimensional figures. When you extend that to 3 variables and you throw this variable z in here, x, y, and z, that adds a third direction or a third dimension. And so that third dimension turns these things into what we call planes. And down here is the images of several different orientations of planes. Think of each of these little rectangles you see as like an infinite sheet of paper. And each one of those infinite sheets of paper is represented by one of these equations. So you get these planes, and you're looking at how the planes are intersecting. And then there's a variety of things that can happen. So for this class, in this section, the only one we're going to focus on is this situation, a single solution where you've got 3 planes oriented in such a way that there is only one point, a single point. Now keep in mind that point is in x, y, z. It's in 3-dimensional space, but one point that exists on all 3 of those planes, all 3 of those infinite sheets of paper. Again, as you can see, there's several ways these planes can interact. All the same, intersect at a whole set of points on a line, not intersect at all 3 places. There's a variety of options, but we're going to focus on the ones that have actually one single solution to their problem. Okay? Now, with that said, the next page tries to outline for you both kind of a little visually and then just straight up step by step the approach we're going to use to solve this. I'm going to very quickly talk through it, and then we'll go through what these steps mean in detail as we do a problem, because there's not a lot of point to just generally speaking about this. But the approach will be, we start with our 3 equations and 3 variables. I'm going to number them 1 through 3. I'm going to number them in circles, that's just to be specific here. We start off with equations 1 through 3. We will do 2 eliminations. So of these 3 equations, you could do 1 and 2, 1 and 3, or 2 and 3. That's your 3 options for pairing them up. You'll do 2 of them, and we'll talk about which ones you choose in a little bit. You'll do 2 of them, eliminating the exact same variable both times, creating 2 new equations that I'm going to call 4 and 5. I'm going to put the 4 and 5 in squares, because those 2 equations, 4 and 5, will be in 2 variables, and at this point, once you've done this is like the new stuff. You will then have created a question that could be just like it was straight out of 5.1. 2 equations, 2 variables. Might be xy, might be xz, might be yz, don't know, but it would be 2 equations with the same 2 variables, at which point we will say, let's think of like a 5.1 question, do an elimination, get our first variable value, get our second variable value, and this whole part of the process right here, going down and back up, all of this is, again, just a 5.1 elimination question. Once you've done this, the only additional step is going back up to one of the first 3 and using the 2 variables that you found here, the 2 numbers you now have, plugging them in to find the third. So like I said, this is the new start, but then this is all stuff we've done, and then that's the little bit to finish it off. And all that stuff that I just mentioned is down here in these steps written out for you. But like I said, we're going to just jump right into the problem so you can actually see this process in action. So there's our first setup, and there are my labeling of those equations, 1, 2, and 3. Now, here's the first important question, and it's very important. Which variable do we want to eliminate? Because like the first step said, we're going to pick 2 different pairs and look to eliminate the same variable both times. So in this particular problem, there's one variable set up conveniently for that to happen. We could do it with any of them, but it would take some work, whether it be x's or y's. But notice z, the coefficients on my z's are a positive 1, a negative 1, and a negative 1. I already have some matching numbers and some opposite signs, even to the point where if I say, and I like to label this just to stay very organized, I'm going to eliminate z in, well, if I say equation 1, that's got a positive 1 in front of the z. So if I go with equation 2, which has a negative 1 in front of the z, I have essentially no work to do whatsoever. I'm just going to rewrite 1 and 2. So x plus 2y plus z equals 4, and 2x plus y minus z equals negative 1. Go straight to that elimination step where the z's will eliminate, and I have 3x plus a 3y, that's gone, equals a 3. A new equation in terms of only x and y. So I'm going to call that equation 4 in a square. And now, the key here is once I've chosen those two with that variable, I need to pick a different two, either 1 and 3 or 2 and 3, but I want to eliminate z again. I have to eliminate the exact same variable, otherwise we gain nothing here. So eliminate z, and notice if I go 1 and 3, I've got another situation where between 1 and 3, equation 1 has a positive z, and equation 2 has a negative z. So no work, no manipulation needs to be done. Straight combining like terms to get a second equation, which I will call equation 5. So to recap, pick any two pairs out of the three possible, but pick ones that are going to be convenient for eliminating the same variable, in this case z in both of them. That will get you two new equations, but those two new equations will have the same two variables. They'll be missing that particular third. And now all I do is I come down here and I say my equations 4 and 5 are 3x plus 3y equals 3 and 2x plus y equals 2. And this is just like a 5-1 question. To solve this, and I'm going to stick with the elimination process, I could easily do that by looking at the y's and just multiply this bottom equation by a negative 3. Right? If I do this, I'm going to eliminate the y in 4 and 5. I won't change this top equation at all. The bottom one getting multiplied by a negative 3 will look like that. Doing elimination, I get a negative 3x, y's are gone, equals negative 3. Now we just divide and get x equals 1. And there, at that point, you now have a value for your first variable. In the steps on the previous page, I even called this 6. You really don't need to do that, all right? I called this 6, but that doesn't matter. It's your first variable. Now, what's important is you take this number, I called this 6, sorry. You take this number and you go back to 4 or 5, right? Go back to one of these because here you have x, you can go back and find y. Well, I'll go back to 5 because 5 even just has just y. So if I bring x back into there, oh, I'm off the screen. So I'll take 5 and put the 1 in for x to very quickly and easily solve for y. Subtract the 2, y equals 0. Now I have x and I have y. Lastly, I'll find z, and this is the step we're adding into the process of taking these and going back to one of the originals. Right? Any one of them, I'll go back to the one that had the positive z in it. I'll go back to equation 1. X plus 2y plus z equals 4, but there goes 1 in for x and 0 in for y. And then we're finding the value for z. So 1 plus z equals 4. So subtract the 1 and z equals 3. And now we have all three variables, x, y, and z, and we write ourselves an ordered triplet of x, comma, y, comma, z of 1, 0, 3. So I know there's a lot there, but just go back and rewatch it. Make sure you understand where those two came from and how we use them to get our first value. And then it's just about back substitution to get our other two numbers. Let's take a look at one that involves a little bit more work. One that's not just directly set up for that very quick and easy elimination. So equations 1, 2, 3. Now again, you can pick whichever one you want, whichever variable you want to eliminate. It does not matter. There may be some that are much more difficult than others. That's the main thing you have to be aware of. So I'm going to go ahead and I'm going to say, let's go with y, just because we did z last time. So I'm going to say y is the variable I want to get rid of twice. So the first time I eliminate y, let's figure out a nice one. Y, here's positive 1. Well, if I go with 3, which is a negative 2. If I go with 1 and 3, okay? Now again, I'm going to do a little bit of work here. So if I'm looking at 1 and 3 and I want to eliminate y, I've got a positive 1y here and a negative 2y there. Well, all I would need is this to be a positive 2, and I'd have what I need. So let me just multiply this by 2. My first equation, equation 1, multiply it by 2. And make sure you multiply everything, even that constant on the other side. But then the other equation, I won't change at all. X minus 2y plus 3z equals 6. And so we get 5x, that's gone, minus z equals 4, and this new equation I will call equation 4. Okay, there's 1. Now, I need to eliminate y, but in a different pair. I just did 1 and 3. I'm going to go 1 and 2, because that's also not far off. So if I go to eliminate y in 1 and 2, again, it has to be the same variable. Then for 1 and 2, notice, I'll just write them down here so we can kind of see what we got. We got 2x plus y. So this is the original of these two equations. Also, I will mention when you are doing these problems, the most important thing you can do is just take your time and make sure you always copy things down correctly, exactly. Double check them, double check your work, because one single missed multiplication or missed minus sign will change everything. And you'll get very ugly numbers and get very confused and do a lot of work that doesn't get you anywhere. So really take your time copying this stuff down. But back to eliminating y, we can say that we can make that happen by multiplying this top equation by a 3, which will make that positive 3y. So 6x plus 3y minus 6z equals negative 3. And then not changing this equation at all gives me that. Doing my elimination, that's gone. Minus 7z equals 2. All right, so from there, we've got our equation 5, and we can take equations 4 and 5 onto our system of 2 equations. 5x minus z equals 4, and 9x minus 7z equals 2. I'll say for this one, it looks like z is going to be the easier one to eliminate, so let's eliminate z. I don't really need to write in 4 and 5 because that's all I've got. I'm going to multiply though. Notice this is a negative z and a negative 7, so I'm going to multiply by a negative 7 to turn that into a positive 7. So negative 35x, that'll be plus 7z equals negative 28, and we won't need to change this one at all. So from there, we're going to get negative 26x, that's gone, and that's a negative 26. So divide both sides by negative 26, and we get our first value of our first variable of 1. Now I'll go back, I'm going to go into equation 4 there, 5x minus z equals 4, and I'll take this 1 and plug it in for the x. So 5 times 1, so 5 minus z, so that means negative z equals negative 1, which means z equals 1. And now you've got x and z. We'll go back and find y. I'll go back to equation 1 because that's got just y in it. And we'll go with x there and y, and z there. 2 times 1 plus a y minus 2 times 1 equals negative 1. 4 plus y minus 2. So that's 2 plus y equals negative 1. And subtract the 2, and I get a negative 3. So it looks like we're saying that x is 1, y is negative 3, and z is 1. Is going to be our solution. And again, you can always check that by simply plugging them back in and making sure they solve all 3 equations. Let's just check that. That'll be a 2. Well, that doesn't work. That means a mistake has been made. All right, so the real question is, where was the mistake made? Stay tuned to find out.